welcome back to another video. I know it's been about over a month since I recorded my last one on Euler's formula, but kind of over the summer I've been doing a lot of real analysis, and this is one of the first proofs you learn in real analysis. And so I'm going to use it, or I'm going to prove it, and then I'm going to prove another result, which is kind of the general case, which I came up with a proof for. So this is kind of the proof my textbook used for the triangle inequality, and it uses, which the triangle inequality, by the way, that I wrote it up here, is the absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y, which is pretty self-explanatory, but proof can be a little tricky. And there's a lot of different ways to prove this. This is just the way kind of my textbook did it, which is I used the Jay Cummings textbook if anyone's interested. But it says that for any x and y as an element of an ordered field F, like the real numbers. So I'm going to use two results here that I'll prove maybe in another video, but you could also try to prove them on your own. This one, actually, that's just kind of a fact, but you could prove this one. This one says that that negative absolute value of a is less than or equal to a, which is less than or equal to the absolute value of a. And this result says the absolute value of a is less than or equal to b if and only if negative b is less than or equal to a, which is less than or equal to b. So what we're going to do to prove this, first say, let's just state the obvious. Negative x is less than or equal to x, which is less than or equal to the absolute value of x, and negative absolute value of y is less than or equal to y, which is less than or equal to the absolute value of y. That's just from this right here. What we're going to do now is, with inequalities, you can just add them together. So we're going to get negative absolute value of x minus absolute value of y is less than or equal to x plus y in the middle is less than or equal to the absolute value of x plus absolute value of y. Boom. So that's our kind of chain of inequalities, I guess you'd call it. What we're going to do now is, let me do it over here actually, factor out a -1, so we get negative times the absolute value of x plus the absolute value of y is less than or equal to x plus y is less than or equal to absolute value of x plus absolute value of y. What we have just done, we actually proved the triangle inequality, because if you put the triangle inequality into the second result right here, where the absolute value of a is less than or equal to b if and only if blah blah blah, all that, this will be our absolute value of a, and this will be our b. Negative b, this is b, negative absolute value of x plus absolute value of y. Boom, that checks out. A, well, this is the absolute value of a, so what's a? X plus y is less than or equal to a. A is in the middle, x plus y. Boom, that's true. What did we say b was? Absolute value of x plus absolute value of y. So that's true as well. Boom, we just proved the triangle inequality. And do the little end proof thing there. And so now, the second and I think much more, I guess, interesting proof of this video, I think it's very elegant actually, is kind of the general case of, I guess that's what I'm going to call it, of the triangle inequality. So say if a1, a2, dot dot dot, an are elements of the real numbers, then the absolute value of a1 plus a2 plus dot 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 plus an is less than or equal to the absolute value of a1 plus absolute value of a2 dot 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 plus an. So as you can see, this is kind of very similar to what we have up here, but kind of an idea I had to come up with, or I came up with, was proving this with induction. And what you do with an induction proof, I'm sure as a lot of people watching know, or maybe you don't know and you're finding out right now, this is your first induction proof. You do a base case, you prove the base case, which would be, let's say, case n equals 1 for this. Then you assume n equals k, so you assume this is true where n equals k, and then you show it's true for n equals k plus 1 using manipulation, inequalities, whatever. So I'll show you, it'll make more sense. And this is, by the way, for all n is an element of natural numbers, for that n there. So what we're going to do is the base case first. I'll show you what I mean by base case. Let's say n equals 1. So that would kind of take that away. It would just be the absolute value of a1 is less than or equal to a1. Boom. We know that's true. So we prove the base case because, I mean, those are equal. So obviously that's true. What we're going to do now, assume n equals k, which means a1 plus a2 plus dot 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 plus ak is less than or equal to absolute value of a1 plus absolute value of a2 plus dot 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 plus absolute value of a sub k. And now what we're going to do is show n equals k plus 1, which is a1 plus a2 plus dot 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 plus ak plus ak plus 1. Sorry, I know this is quite a bit of writing, and is less than a1, absolute value of a1 plus absolute value of a2 plus dot 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 plus ak plus ak plus 1. Boom. We're showing this. So the first thing I'm going to do is I'm going to put this in parentheses, this kind of original thing. I'm going to call this r. So r equals a1 plus a2 plus dot 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 plus ak. You know that's just some real number, so I'm just going to call it r. What I'm going to do now is I'm going to use the triangle inequality, that we proved earlier in the video, to show something. Basically, I'm going to show that r plus ak plus 1 is less than or equal to, by the triangle inequality, this is less than or equal to the absolute value of r plus the absolute value of a sub k plus 1. Remember that r equals this over here. That's a k. Now, I'm going to use our assumption. We assumed that n equals k and that this was true. Let me scroll down a little bit. We assumed that this is the absolute value of r, by the way. We assume that the absolute value of r is less than or equal to a1, absolute value of a1 plus absolute value of a2 plus dot 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 plus absolute value of ak. What I'm going to do to this inequality is add the absolute value of a sub k plus 1 to both sides, which doesn't change anything. It just basically, it's just rewriting it. So we're going to get, remember, this is just the absolute value of r right here. Absolute value of r plus a sub k plus 1, our absolute value, is less than or equal to a1 plus a2 plus dot 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 plus a sub k plus a sub k plus 1. And notice how this expression right here is the same as our assumption, so it's also true. And now all we have left to do, notice that these are the same right here, so we get r plus a k plus 1. Combining this all together, this right here is less than or equal to the absolute value of r plus the absolute value of a sub k plus 1, and that's less than or equal to a sub 1 plus a sub 2, absolute value by the way, plus dot 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 plus a sub k plus a sub k plus 1. Boom. So this leads us to show that the absolute value of r plus a sub k plus 1 is less than or equal to the absolute value of a1 plus absolute value of a2 plus dot 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 plus absolute value of ak plus absolute value of ak plus 1. And now, basically, so what we did there was just get rid of this middle term right here, because I mean, obviously those are also less than or equal to each other. So now I'm just gonna sub in r. Sorry, this is my last time writing all this, I swear. So therefore, that's the shorthand for therefore, if you didn't know. Subbing in r for here, a1 plus a2 plus dot 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 plus a sub k plus a sub k plus 1 is less than or equal to the absolute value of a1 plus the absolute value of a2 plus dot 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 plus absolute value of ak plus the absolute value of ak plus 1. Boom. What did we just show? We just showed n equals k plus 1 is true, using our assumption and the triangle inequality. So yeah, that basically completes our proof here. I really hope you enjoyed. If you want to see more real analysis videos, higher math videos, whatever you want, just leave suggestions in the comments, like the video. Yeah, I hope to make more content soon, and I hope you enjoyed the video.